This question's not from any past paper, I've just made it up myself. I just want to showcase how we're going to solve something where the inside of the trig function is a bit weird and the range is also a bit weird as well. I'll also point out the common mistakes along the way that students often make. Well, the first thing that I notice is that we've got something squared is equal to a number. That means that if we want to find that something on its own, then we might want to take the square root of both sides. The square root of a quarter is a half. This is where mistake number 1 often happens. Don't forget your plus and minus. Minus a half squared is still a quarter. So I'm going to separate out into two cases. Either cos 7 over 3 theta plus 10 is a half, or cos 7 over 3 theta plus 10 is minus a half. We'll solve them both separately. The next thing we can do is we can find the principal value of cos. If we do the inverse cos of a half, we should get 60 degrees, like this. We can do the same thing over here. If we do the inverse cos of minus a half, then we should be able to get 120 degrees, like this. That's the principal solution. That's the one that the calculator gives you. According to the cos diagram, which looks somewhat like this, if there is a solution at 60 here, there is also a solution at 360 minus 60, so 300. Similarly, if there is a solution at 120, which is roughly here, there is also a solution at 360 minus 120, which is 240. So that's my principal value, and then what I like to call a secondary value. How do we know if we're going to need to find more values? Well, that's where we're going to change the range. Let me get the range up here. The range is between minus 90 and 270. But in our question, theta is a bit strange. So what we can do is we can times both of these numbers by 7 over 3 and work out what the new range will be. So I'm going to divide by 3 and then times by 7. I'm going to get minus 210 and I'm going to get 630. That's not quite what we've got written here inside the big bracket, so I need to add 10 to both sides. So the solutions that we need to find need to be between minus 200 and 640. So what we can do is we can take each of these values and add and subtract 360 until we've got all the solutions in that range. Let's start with 60. If I subtract 360, it's minus 300. It's already too small. But if I add 360, we get to 420. That seems pretty good. That's in the range. If I add 360 again, too big. Yeah. If I add 360 to 300, 760. That's not going to fly. But if I subtract it, we get to minus 60, and that's within the range. If we subtract 360 again, it's too small, it's too negative, so we're going to stop there. Over here, if I add 360, I'm going to get 480. That seems okay. If I add 360 again, then it's going to be too big. And if I subtract 360 from 120, then it's going to be more negative than minus 200. So those are the two solutions. What about for 240? If I add 360, I'm going to get 600, which seems okay. And this time, if I minus 360, I'm going to get minus 120, both of which are in the range. So don't assume that it's always going to be two solutions, because sometimes it might not be. A common mistake from this part is not finding all the solutions now, but rather at a later stage. You have to find all the solutions now and then rearrange the original. If you rearrange now and then find the extra solutions later, you'll find out some of them just won't work. And now we continue we know that 7 theta plus 10 is equal to these four values. So let's just take away 10. We're going to get 50, 410, nope, 290, and we're going to get minus 70. And similarly on the right, we're going to get 7 theta is equal to 110, 470, 230, 590, and minus 130. This means that 7 theta is going to be, if we times everything by 3, 150, 1230, 870, and minus 210. And then over on the other equation, times them by 3 again, 330, 1410, 690, 1770, and minus 390. And then it's time to divide everything by 7. 7 is not going to go into most of these, so what I'm going to do is I'm going to calculate each one individually and then just round it to 3 significant figures. And I've combined them all into just one line. Theta could be any one of these values. You don't have to put them in numerical order, so I'm going to leave it like this. Chances are you won't get a question with quite so many solutions, but it should showcase how to find all the solutions if there are many in the range that you need to find. Well, there you have it. That's another question complete. Hopefully you won't get something quite so nasty on your exam, but if you do, now you know what to do.